So the next problem, it is based on the same concept, but there is an extension to what we have done so far. Okay, so the question is like this. Okay. The source emitted by this information source is S1, S2, S3, S4, and S5. Okay, and the probabilities are in this way. Okay, so that is a 0.12, 0.08, 0.15, 0.4, and 0.25. So in this case, they are asking us to find out the, so first part of the question is find the Shannon's coding, right, for this given data. And part B of the question is to find the coding efficiency, and the redundancy, right? That's an added part. So S and P are given, right? Directly we'll start solving the problem. But in the first step is to write it in the decreasing order, correct? So let's write the probabilities in the decreasing order. So probability should be highest one is 0.4, then we have 0.25, then I think 0.15, 0.12, 0.08. According to them, write the source. Okay, so 0.4 is for S4, then 0.25 is for S5, 0.15 is for S3, then 0.12 is S1, then S2. All right, so that is done. So now we need to calculate what is the second step. If you remember, this has to be the lengths, correct? I have to calculate the length of each of the symbols. So, right, so that is step number 2, right? Calculate Li such a way that it should be greater than or equal to log to the base 2 of 1 divided by the probabilities. So start with the first one. So L1, it should be, right, greater than or equal to the log to the base 2 of 1 divided by 0.4. So the first one, L1 comes to be 1.32. So what we do, we take L1 to be equal to 2, right? Yeah. Yeah, next value is 0.25. What happens to the log to the base 2 of 1 by 0.25? exactly 2. So we retain that. Okay, that itself is 2, L2. So the next comes to be 2.7. So this implies take L3 as 3. Yeah. So this is 3.05. Next number, always greater. Okay. There is no lesser, right? So you will make this as 4. So L4 is equal to 4. 3.64. So you will make sure that L5 becomes equal to 4. So we got all the lengths. So move ahead and go to the step number. This is step 3. Okay, start with the various parameters such as Q1 equal to 0. Okay, so Q2 becomes equal to the Q1 plus P1. Q1 is 0 plus what is the first probability we have written here? 0.4, right? So this is 0.4 is the first parameter, that is Q2. Q3 is equal to Q2 plus P2. Okay, so 0.4 plus 0.25. So 0.65. Then Q4 is equal to, this is P3 plus Q3. All right. So 0.65 is my Q3. And to this, I'm going to add 0.15. So that is 0.8. Q5 is equal to Q4 plus P4. Okay. So we know that the Q4 value is calculated as 0.8 plus 0.12 is the next probability. So this is 0.92. So Q6, this is the last one. So that is Q5 plus P5. All right. So 0.92 plus 0.08 gives you 1. So yes, calculation looks fine for us. So now I need to represent the each of the Q1, Q2, Q3, Q4, Q5, right? By using the sufficiently large number of bits, that is L1, L2, L3, L4. So that is the step number 4, right? Convert your code into the code root, right? So Q1, what is Q1? Q1 equal to 0 to the base 10, right? I know that this has to be of length equal to 2, right? Right. So once again, it remains same. This is simply 0.00 to the base 2. Then go to the Q2, which is 0.4 to the base 10, right? I need to represent this also as the length equal to 2, correct? Right. So that means, so do the conversion. So 0.4 into 2 is 0.8. So first number is 0.0. Then this 0.8 multiplied by 2 is 1.6, right? So next number is 1, right? I think that is sufficient. I just want 2 length, correct? So simply hold on to this. You don't have to calculate further. Okay, Q2 is over. Go to Q3. So as I can see, the Q3 is now 0.65. Okay, so 0.65 is to the base 10. So do the calculation. 0.65. This has to be of length 3. So I should do up to 3 decimal places. Okay, after the count. So 0.65 into 2 is equal to how much? 1.38, right? So this one goes here. 0.3 into 2 is 0.6. So next digit will be 0, right? Then this 0.6 into 2 gives you 1.2. Next one is 1. Okay, so I need three places, so three I got, so I'll put on. That is Q3. Right. Next, if you see the Q4 value, what is the Q4 value? Q4 value is 0.8 to the base 10. Okay, convert this into the binary and tell me. Okay, we need I think four places. Okay, four decimal places. So this is equal to 0.1100 to the base 2. Similarly, we need a Q5. Okay, so Q5 is 0.92 to the base 10. All right, please convert this into the decimal places, binary to the base 2. And I think we need again 4 bits. So this is equal to 1110 to the base 2. All right, so we got the codes and now we can write the results. Maybe can represent in the form of a table, right? So what's the first symbol that we are generating here? The first symbol corresponding to Q1 is S4. So this is in the same order: S4, S5, S3, S1, S2. Okay, S4, S5, S3, S1, S2. So corresponding to them, we have generated the various code words. So let's look at the code word and let's write them. So first one is 00. So S4 has length 2, that is 00. Then the second one is 01. This is also length 2, 01. Then we have 101, then 1100, and the last one is 1110. Okay, so that's the first part of the answer, right? Now we need to calculate the efficiency and the redundancy. That is part B. So I know that the efficiency eta is equal to h of s divided by the length into 100%. So this is what I need to calculate. So first let us calculate the h of s, right? H of s is equal to probability, right? That is pi log of pi, correct? Summation pi log to the base 2 1 by pi. So for all the symbols, let's do this. So that is equal to 0.4 log to the base 2 1 by 0.4. Next is 0. How much? 3, no, 0.25. So 0.25 log to the base 2 1 by 0.25. The next number is 0.15 log to the base 2 1 by 0.15. And the next number, it should be 0. Plus 0.12 log to the base 2 1 divided by 0.12. Then 0.08 log to the base 2 1 divided by 0.08. Please calculate this. So the length, the average length is 2.55. Okay, so now directly apply the rule to calculate efficiency. Is equal to h of s 2.09 and this is 2.55 into 100. 81.96%. So this means I have a redundancy that is equal to 100 minus 81.96. So that is 18.04. Okay, this is the required answer. All right, so I'll give a problem to solve now. Okay, so the source generates 6 symbols. 1, 2, 3, 4, 7 symbols. All right, so that is A, B, C, D, E, F, G. Okay, with the probabilities mentioned like this. Okay, so that is 9 by 30, 9 by 32, 3 by 32, 1 by 16, 3 by 32, 3 by 32, 3 by 32, and 9 by